I drive my car up to the lake as if there's someone to awake. I haven't been to bed for days, I live in a twilight haze. I set my heart to the setting sun, and I hope that no one else has done it, and the drinks are never far. Open up the bar. I miss you every single day. I wait until
I'm going to start the podcast, so if you're ready.
Yeah, I'll just grab a seat.
Oh, yeah, cool. Sweet, man. Thanks for coming in so early in the morning. It's always a bit random, even for Milton and I, to think, why are we doing this?
Yeah.
So when you came in yesterday and asked me, I was like, why do we do this? It's ridiculous. Hey, so now your business is called VQuest, and we were just talking about what the V stood for. It's more of a Roman numeral than the letter V.
Mm-hmm.
So tell us, I don't know where to start. I'm not really too sure where you should start, but
Sure.
Since you've got such an amazing accent, tell us how you came to be in New Zealand.
Sure, okay, that's a good place to start. Yeah. So obviously the accent is Irish. I'm from Cork. I came across to New Zealand during the earthquakes here in Christchurch. So just after the first or the second major earthquake. I had come from Ireland where the construction industry had collapsed almost in the space of 6 months. It had been a booming industry for about 20-25 years. It was it was the number one industry to be in, and their whole economy was based around construction. The GFC hit, global financial crisis hit, and it hit Ireland probably worse than most.
Yeah.
And our construction industry went from working 6 to 7 days a week, working through holidays, working late into the night, because there was a lack of resource. In 6 months' time, or in 6 months after the GFC, it basically went to nearly 60-70% unemployment in construction. So a lot of professionals at the time came to New Zealand. They went to Canada, went to the UK. I ended up here in New Zealand because my brother has actually lived here for about 20 years now.
Oh, cool.
Yeah.
Wow.
Yeah.
And what were you doing when you...
So my profession is quantity surveying.
Yeah.
I started in quantity surveying in 2001, and was doing it all the way up until earlier this year.
Right.
Yep.
So do you have a background in code? Because tell us.
No.
Yeah, tell us what VQuest is like. Because you've just launched this year, essentially, haven't you? Or done a pivot from a previous...
Correct, yeah. So we started working on VQuest, myself and my co-founder, about 4 years ago. We saw an industry demand coming, and we were actually working on something else. We were working on what we call a quantitative surveying solution to building information modelling. And we were using a system that with a lot of workarounds, an existing system, and we said, right, well, we can actually improve this. So that's what we had started working on. Mm-hmm. We could come up with something better than the industry currently has, and we can release it to the market for other quantity surveyors to use. We were using that system ourselves in-house in a consultancy business that I was a partner in.
Yeah.
And we had a client come to us and said, we've seen what you guys are doing, the systems you're using really aren't being used anywhere else in New Zealand or even Australasia, if not the world. The workarounds we were using was through building modelling. So we were doing parametric modelling using quantity surveying. So you have architects and engineers that use parametric modelling. All that really means is it's a 3D model, a dynamic 3D model of the building.
Yep.
What we were doing was we were rebuilding those models in full detail. So architects will only design to maybe 70%, 80% of the detail. They won't draw everything.
I see.
They will draw typical details.
Yes.
That's not good for a quantity surveyor because a quantity surveyor has to measure every single element of the building. Now, so what we did basically was we were remodeling the buildings with all of the detail in them, and then we were embedding it with cost data. So when you made a change to the model, it automatically updated the cost data.
Yeah.
Now, the industry doesn't do it like that. The QS industry doesn't do it like that. They manually measure everything, and if there's a change, they have to go back and remeasure it, right? So that's how we were a little bit different in our consultancy.
Man, and there's just so many opportunities for errors to happen, like human errors. Or,
exactly. Yeah, it's open to human error, and it's also very, very labour intensive to go back and remeasure things.
Yeah.
So this client came to us. They had a larger program. They saw what we were doing, and they saw that what we could do was build a model for their building as it was meant to be built.
Yeah.
And then very quickly change the materials, we say, from what they had designed it to another type of design, so another methodology. So as an example, they had this particular building that we began with was a mass timber building, which is a newer technology in New Zealand where you build as much as possible out of timber. So you replace your structure steel with mass timber like LVL type timber, glulam type timber, and CLT cross-laminated timber. To replace all your structural elements. And that's how they had built it. That's how they were wanting to build it.
Yeah.
But they had no metrics or no way of comparing that building to how you could, if you were to build it traditionally, how much would that have cost?
In steel
and concrete.
Yeah.
So they said to us, look, your system is perfect for, with all our workarounds, for doing a comparative analysis of different methodologies of building this building.
Yeah.
So we started doing that. We started working on it for them, and they brought us in as a nominated consultant to their entire program, and which was about 15, 20 buildings, to do comparative analysis of different cost models for different types of buildings. So warehousing, hospitals, apartment blocks, right across multiples.
So can I just go back? Who were they? Were they engineers or were they project management? Or?
No, they were actually government industry. So it was a Ministry for Primary Industry.
Right.
So what they were trying to do was promote mass timber products.
Yeah.
And what they realised was that there was a lot of misconceptions in the market around mass timber being too expensive, being too hard to use, having a lot of hidden costs, having a lot of knock-on compliance requirements. And what they wanted to do was build multiple case studies that showed or disprove some of those misconceptions, or prove them, and it meant that they had something to work on.
Yeah,
you know?
and they had a sort of a ready and waiting line of projects that they're constantly doing, aren't they?
Well, so MPI were effectively partnering with developers. So developers were saying, look, we're open to using mass timber, but we don't see we can't see the benefits of it, or we haven't been able to prove the benefits of it. So MPI came in and said with their program, which was called the mid-rise wood construction program, they were basically co-funding those projects or co-funding the design of those projects.
Yeah.
The benefit to us was we got to compare multiple buildings across different cost models using our existing system that we were using. And it was great. We were able to do it, and we were able to build great case studies around how those buildings what they would have cost and looked like if they had been built in different methodologies.
And what did you find?
We found that there was a premium to be paid for your mass timber buildings, your sustainable buildings.
Right.
It was about 2 to 3%, but the industry at the time was saying that it was around 6%.
Right.
Now, what we were able to prove was it was considerably less than that, and there was an issue in the market with the way people were assessing these buildings. They weren't accommodating for the fact that it's quicker. These buildings are quicker to build.
Yeah.
So it meant that you had less craneage, you had less scaffolding, you had less durations on site, which should reduce down the price. Now, the market wasn't really properly considering that. We were able to prove that once you reduced all of that down, it came closer to a traditional build. Now, there are some instances where those mass timber builds actually do make sense. They actually can come in at the same price as a traditional build, or can actually add benefits in other directions that increase your yields on your buildings. So that's what we were doing at the time, and VQuest was trying to build a better version of what we were doing in-house. So commercialise what we were doing with all our workarounds and all of our tricks and hacks to the system. MPI at the time said to us, listen guys, what you guys are doing is fantastic. Is there a possibility here that you can do carbon? So carbon analysis, your carbon emissions, your upfront and carbon emissions that are emitted in producing the building. And we said, look, we've never come across this before. We don't know, we don't understand what carbon emissions are.
No one knows what carbon is, Barry.
So
literally.
It's greenhouse gases. That's what carbon is. Right, and it's the emissions that in producing a material and building a building, and operating that building, how much of those emissions are go out into the atmosphere. So that's what carbon is. Carbon is just a way of...
It's become such a common phrase. And so now does it embody other things? Like...
It's
like emissions, sort of.
Yeah, so that's why they just call it carbon, is because
Yeah.
it's complicated. The greenhouse gases, there's multiples of them.
Yeah.
And then from a building perspective, there is multiple types of carbon in a building. As in, you've got your MBIE have a roadmap here, or have a way of explaining it where they put it into modules. There's like 7 or 8 modules where they put it into. And it's all to do with the mining, so getting where your raw materials come from, that's your first module. The production of the actual material, when you combine all those materials together, is another module. Your transport to site or your transport to another factory is another module. Your construction on site is another module. The operating of the building is a module.
Yep.
The maintenance of the building is another module of carbon. And then the end-of-life demolition and disposal of those products is another module. So
that is an entire, I think they call that cradle to grave, do
Correct.
they? And they're trying to create these closed loop type of things, aren't they? Scenarios.
Yeah. They're trying to get to a scenario where we're reducing our carbon, and the best way to reduce our carbon is actually not to produce new materials, it's to reuse the existing ones we have. That's the ultimate goal, is keep reusing the materials we've already made. So MPI came to us and they basically said, look, your system is fantastic, we love the way it works. Is it possible for us to, because you're already embedding cost data, to embed carbon emission data into it as well?
Yep.
We said, look, we've never tried it before, we're not even fully aware of what this is. So we started doing some research and began to realise that on the most basic levels, without having to understand the negative or positives of carbon and all the issues that it has for the environment, on a most basic level for us, it's just a set of data. It's a set of metrics, or performance metrics of a material. So we were already embedding the cost metrics. We said we should be able to embed the carbon metrics.
Yep.
So we started doing it. We started looking at getting the carbon data, putting it in for the products into our models, into our 3D models, and seeing when we compared our different models or methodologies of buildings, so our mass timber building versus our traditional building, we could now see a cost analysis and a carbon analysis of the two of them.
Yeah.
So we realised that we can actually do that metric, and we can do cost metric. Is there anything else we can do?
Yeah.
So we started looking at, mass timber buildings have another issue that people don't fully realise. They're way lighter they don't weigh as much as a traditional building. Concrete and steel is much heavier. And that has knock-on effects that nobody can ever really quantify at the earliest stage of a project, is how much lighter is it? So therefore, how much less should it cost? How much smaller should the foundations be? Is it less of an impact on the land, which means you have less land remediation? So we said, that's another metric that's unknown in the industry, so let's see if we can address that one as well. And it's simple because it's another set of data. Yep. All we do is we embed the weight data of all the materials into the model as well. So now we're looking at carbon, cost, and weight.
Yep.
And our models have multiple metrics in them, and we can do multiple comparisons. The great thing about it is, for us, is that when you push on one of those metrics, typically the other one changes. So if you push on reducing carbon, your cost changes.
Yeah.
If you reduce your weight, potentially your cost goes up or could go down. Or your carbon can go up and go down as well. So 3 metrics that actually are interacting with each other all the time, and because of that, they're complicated. So we realised we were solving quite a big issue here for the industry, in that we were giving data to the industry that would allow better decisions to be made.
Yeah, man.
So we realised that MBIE were coming out with new legislation, part of the Paris Climate Agreement. All the governments around the world that have
2025.
Yes.
Is it? I mean, that's just around the corner.
Yeah. So 2030 is the first metric we've all signed.
Oh,
up to. 2030.
Right.
Yeah.
Okay.
So that's that we reduce our carbon emissions by 50%. Right,
50%.
50%. Right?
Oh, yeah. And is it 2050? It's meant to be sort of net zero.
Net zero. And what net zero means is that we can't prevent ourselves from producing carbon, but we're doing enough to offset it.
Right.
So we're effectively neutral.
Yeah, I see.
So we realised that this is going to be a huge thing. This is actually going to change the way the construction industry builds. And the likes of mass timber and sustainable products are going to become more popular, because we're now trying to achieve more than just the most cost-efficient way to build a building. It's also now going to have to meet thresholds or metrics that make it sustainable as well.
Yeah.
So we realise when developers are going to start building buildings, they're going to have to look at the feasibility of building and the feasibility of sustainability.
Yeah.
Or else they won't be able to afford to build, because they'll be penalised for building unsustainable buildings. or they just won't be given permission to build those buildings. That's some of the metrics that the likes of MBI are looking at. They're looking at penalisation thresholds, that if you cross over them, you'll either be penalised, you'll either have to pay for offsetting the carbon that you're producing, or they'll actually just say, no, you can't build those buildings.
Right.
So they're looking at those, and governments all around the world are looking at that same legislation.
Man, I mean, penalising people doesn't seem to be a very sort of forward-thinking way to regulate an industry, but I suppose it needs to exist to a certain degree, like at the far extreme. But I mean,
it's we already see it with we've seen it for the last couple of years with the automotive industry, where the EVs have been, you've had
that's right,
no road user charges, so effectively the combustion engines were being were being penalised.
True.
I mean, so same with building industry.
So for existing buildings.
No, this will be for new builds. New builds only. Yeah,
okay.
New builds only.
Wow. So you got these three variables. What was it? Weight, carbon, and cost.
Yeah.
Right.
Yeah.
And cost is very sort of relatively black and white. Weight is relatively black and white, but carbon potentially seems a little bit more grey to me. So, because for instance, although I suppose what I was going to say is, if you were building something way out in a remote location, I was thinking all of those things would be affected, like the carbon to transport the materials to site.
Yep.
But that would, once again, like you point out, it's not going to affect the weight, but it would adjust the price.
Correct.
Yeah. So those two are real closely related.
They are. Yeah. So it's and your cheaper products tend to be lower or tend to be higher in carbon.
Yeah.
You try and reduce the carbon or go for a product that's more sustainable. It potentially has the potential to put up the price.
Yeah.
That's again, it's not always the way. There's variables on that as well. So it's a complex subject of a lot of moving parts.
Yeah.
What we've done is we've built a system. Now, what we also saw was that quantity surveyors, what we were originally building our software for, weren't actually the bottleneck, or weren't going to be the ones assessing this carbon issue, right? It's going to be architects. Architects and engineers, designers would effectively be the bottleneck of that information.
Yep.
In that, the way it currently works is your architect and engineer go through design phases. So they go through concept design, then they'll go on to preliminary design, develop design, and then into detailed design, and eventually construction set of drawings. So they go through multiple phases. And what they will do is they'll do an entire design phase, and then they'll hand it over to a quantity surveyor, and the quantity surveyor will price it. So the quantity surveying is already lagging behind, right?
Yeah.
So if it's the quantity surveyor doing the measurement of the materials, which is where the calculation of the carbon happens, it means that we get to the end of a design process before we figure out we have a problem.
Yeah.
Right? So the bottleneck is the architect. They don't, and the engineer. Not that they're a problem, but that they have a lack of access to data.
Yeah.
Right?
Yep.
So what we said was, it's not much point in us building those modules that we were talking about, carbon cost and building mass, into a QS solution. We should be targeting architects and engineers, because they need that information earlier than currently has been given to them. So
there's an interesting rivalry between engineers and architects, and within the my sister's an architect, and
it's a funny one. It's right across the construction industry. It's quantity surveyors and architects as well.
Oh yes, yeah.
You have architects who want to build beautiful buildings.
Yeah.
You have engineers telling them it's not possible, and you need to simplify it. And then you've quantity surveyors telling them you can't afford it.
Yeah. Isn't that a great kind of? It's kind of a beautiful picture of humanity, because that goes on in so many other different realms as well, right? You've got the artist, and you've got the passion and the thing, and stuff. Oh, well, that's cool, but so they are the problem.
Well,
you said it, Barry.
Yeah, they're the bottleneck. The bottleneck of data starts with them. That's what it is.
And that's like sustainability and stuff. We've realised that we need to get in there, design it out right from the beginning.
Yeah, 80% of the opportunity to reduce carbon in your construction is at the first stage of design, first two stages of design, concept and preliminary. If you leave it to any later than that, you've reduced your whole opportunity to 20%. You know what I mean? It has to be a consideration from the very, very beginning.
I imagine that architects would totally be into it, because quite often they've got that avant-garde kind of thing, and they're wanting to embrace new things, new technologies, and So is some of the timber that you're sort of substituting for the, taking away the steel and the concrete, is some of that timber like a new kind of technology, or are there new aspects to it where we're able to do more with it than we previously have?
Yes and no. That technology has been around for a long, long time, but not properly utilised. In Europe, it's been around for 50, 60 years.
Yeah, cool.
And what it is mass timber products. What they are is just plywood. Made bigger, So bigger plies, bigger membranes of plywood, So a big chunkier structure.
Fair enough. I mean, that's what steel is, right? I mean, you get different grades of steel, and you want something super strong. Well, you go for a big one.
So it's new to New Zealand. New Zealand has used timber as well, but used it in the more simpler form of just stick built timber. So you're framing.
Yes.
Yeah. You go back to older buildings. There's a fantastic one out in Addington, the mill out there.
Yeah.
You walk into that building and it's got real old, real chunky structural timber, and it's really cool to walk into. They've turned it into shared office space, I think. That's a really cool building. So that's an example of how we did use timber. Yeah. And we've moved away from it because structural steel was cheaper, quicker, faster.
Who knows? We probably had a deal. Political reasons, and
So, and we import all of our steel. What I mean? All of the raw materials, all of the most of our steel is actually imported. So we've got all that import carbon as well.
It's dug up here. It travels there. It travels all over the place.
And so that mass timber it's a fantastic product, but our system is agnostic of any selecting any material, right? Ultimately, it's the metrics that will play it. Yes. In some instances, mass timber doesn't work, so our system doesn't recommend mass timber in that scenario. You know what I mean? So what it's doing is it's using the metrics to understand what the best material is to use in the best location.
Yeah. So it's not just a case of always
exactly
with every build just swapping now with timber.
Exactly.
So what other materials?
Yeah. So and this is it adversity drives innovation. Yeah. And the concrete industry is suddenly realising it's probably one of the biggest. The concrete and steel are the biggest emitters, right? And they're realising that they've got a huge problem, and that they are not going to be able to compete with timber from a sustainability perspective. So they need to start working on solutions, and they've come up with a couple. They're not perfect and they're not cheap, but that's going to change over a period of time as they get better at this and the science becomes better. So you've got low carbon concrete. Fletchers are using it at the moment in a low carbon construction house that they've just built. It costs more, but it's got considerably less carbon in it. Yeah. They put additives in that reduce the carbon in it.
It's the same with food, Barry. Like less sugar, it costs more. They minus things. They take stuff out of the food, but nevertheless it goes up.
Yeah. I'm sugar free, so I understand that. Everything I buy is sugar free.
Yeah. That's a premium for you.
Yeah. And there's a fantastic startup company here that came out of the University of Canterbury. They're called Aspiring Materials. And if they can achieve what they're setting out to do, it will revolutionise the construction and infrastructure industry from a concrete perspective.
Yep.
They are taking aggregate, so stones, rocks, pebbles that we use under our roads, we use in our concrete, and they're elementally deconstructing them. So they're using a chemical process to deconstruct it and separate it into its individual materials. They're using another chemical scientific process to put that material back together in a way that it absorbs all the carbon around it. So it's going to store carbon that's in the atmosphere. It's going to pull it back into the rocks. And then they're going to bury those rocks on the roads and they're going to put them in concrete. And that will effectively make construction of roads, construction of foundations of buildings, carbon neutral. It'll store the carbon rather than emit carbon in its production. So all that innovation is going to happen, and every time a new material comes out, we've now got a new material to assess.
Yes.
We've got a new material that comes into our system that architects are going to want to know, does this material work in this location? Is it cost effective, and is it a sustainable material that we can use? So
is there currently like a criteria or a standard that is applied to materials, like a third independent sort of party that assess the material and give it a figure?
Yeah. So at the moment, it's the responsibility of the manufacturer to
Right.
come up with that information, right?
Ooh.
No,
We've seen we could get into trouble there.
We can do, but they do have to engage a third party. They can't do it
Yep.
themselves. They
Okay.
have to engage with building scientists. So you'd hope that, and they're paying those building scientists. You'd hope that the systems are strong enough to
Yeah.
say that
Yep.
that works, right? That's called EPD, Environmental Product Declaration. So,
Yep.
and as we move forward into this legislation, every product that's going to be used is going to have an EPD. So, your windows and doors, your glass, your tiles,
Yes.
your the timber that
Yeah.
goes into your building,
Yep.
every product that we use in construction is going to have an EPD. That's where the carbon data comes from. So,
Yeah.
our system basically pulls in that EPD, extracts the carbon data, does the analysis of transport to site, end of life, and removal of the product, all of that.
Yeah.
So most of that the carbon data is in that document as raw metrics, and then the system analyzes it, understands right across all the modules, the life cycle, cradle
Yeah.
to grave, how much carbon is actually emitted in this building using that product.
Yeah. It almost doesn't seem fair that a material should be judged on its end of life type of thing, because, you know, people build buildings often, and, you know, in Europe,
Yeah.
there's buildings that are seriously old.
Yep. Yeah, you got to. Materials are designed for a certain period of time. We don't. And if a building's maintained really well, fantastic. They last a little bit longer.
Yeah.
But there's recommended durations that you're meant to replace things in.
Okay.
But it would be great if we could keep them. You know, if we can maintain them and they last longer. But they have to draw a line in the sand somewhere to say that.
I guess so.
And with newer buildings, those materials don't last as long as the older brick buildings that you've got in the UK. One of the great things that's happening in Europe, and it would be great to see it happen here as well, is their legislation is starting to look at the assessment of existing buildings and retrofitting. So they're going to now say, some countries, like Germany and France, are bringing out this legislation that says you are no longer allowed to demolish that building. You have to first, before we give you permission to demolish it, have to prove that it can't be reused.
Yeah. And potentially, yeah, I see.
So then that prevents the amount of carbon going into the atmosphere, because we're reusing an existing building and we're just retrofitting it.
Yeah. Yep. So you're even looking at the different scenarios exiting.
End of life, yeah.
To be fair, I kind of understand, you know, they weren't thinking about it too much in the Dark Ages. Or were they? Who knows? Hey, that thing about the concrete. I've heard one time people talking about concrete, and they talk about the particles and the sand that they need for it, and they can't just use sand off the beach or sand out of the desert. It has to be a particular shape.
Yep.
And to provide the structural integrity of concrete. And that is, I don't remember the whole, you know, the whole gist about it, but it was a massive industry, and it really went up and down, and they were having some shortages of this particular type of sand that they required for concrete.
Yep. Yeah. During COVID, the likes of Jib, Winston Wallboard, had major issues getting their materials.
Yeah.
You know, so out of Australia, most of the gypsum was coming from Australia. They tried to bring it from somewhere else. Yeah. And it messed up their machinery. You know what I mean? Because again, it was just you know, marginally different, and it was enough to mess up their systems. You know what I mean? So it's that. It's
on a molecular level, practically, isn't it? Yeah.
There's a science behind it. What materials can be used where, you know. So yeah.
Flip. You wouldn't want me involved. I vacuum up the dust from my sanding all the time. I've destroyed multiple vacuum cleaners.
Yeah. My partner gives out to me for we have a batch on the west coast, and she gives out to me for hoovering up the ashes from the from the wood fire with, you know, just the last of it, you know. But I've ruined a couple of vacuums that way as well.
Yeah. Wow, Barrett, this is pretty impressive. So you've received funding at different stages.
Yes. Yeah.
And so you have recently kind of, how long did it take to pull all of this together and kind of put it into a product, create that product?
So we started 4 years ago, and we got to a point where we had a minimum marketable product in January. Well, we had it in December, but we figured all your architects go on holidays for December and January. Yeah. So it's pointless releasing it at that point. So we...
architects.
Yeah, architects. It gives all the rest of us an excuse to go on holidays as well, you know. So we figured it wasn't much point in releasing it in December, so we came back January, and then we released it in February with an early adopter program. Where what we've done is we've basically released it to about 20 or 30 users. Architectural firms, actually we had a tag of Polytech yesterday, agreed to take it up as well.
Wow.
And use the system for a space of 2 months for free. And what they're doing is not that they're beta testing, because we've been through all of that. It's more user interaction. We want to see what they're using, how they're using it, build case studies out of their first projects, and use them as advocates, basically. So go to them and say, here's a survey, can you give us back some great information as to how you're using the software, what you think of the software, and then we'll use all of that information to market the product, as well as go find more funding, go to more venture capitalists or investment funds and start raising funds so that we can scale and get across to the likes of Australia, which we want to do really quickly, because the Australian legislation is ahead now of where New Zealand is. Where it was behind.
Right. With
the national government coming in, everything is slowed down here. And the legislation is going to be a massive driver for us. If without the legislation, our market is much smaller, because whilst architects are interested in sustainability, there's no driver there or no mandate there to say they have to build sustainable. So they will all, they will most likely, unless you're an architect working in the sustainable environment, probably won't start to reduce carbon until you're told to. For sure. Australia is going to release their legislation third quarter of this year, whereas New Zealand has gone quiet. We don't know. They said it was going to be 2024. It is now impossible for it to be 2024. It's too late. But so it's our funding to here has been MPI came on board, and they gave us a nice grant to get us going. When we showed them what we were working on, we went and presented a proposal as to how we could actually scale this product and give benefits to New Zealand. They gave us some funding to actually get us going. That was about 2 years ago. And then we had a venture capitalist from the North Island, again, saw what we were doing. He was involved in the construction and sustainability industry, and he decided, this is actually a great product.
That's awesome.
Yeah, so he came
Did you go through an innovation hub or some kind of...
Yeah. So we went through Ministry of Awesome.
Yeah.
We were in their 2023 winter cohort, and a fantastic program to be involved with, because you got access to mentors, filling in the gaps of what we don't know, because we came as quantity surveyors into this whole tech industry that, whilst we're tech savvy, we've never tried to build anything, and we've never tried to sell or market, or we were always just a consultancy. MOA provided all the mentors around that gave us advice and told us what documentation you need to have in place, how you build your marketing strategies, how you attract funding, what insurances you need, all of that sort of stuff. So they were great, and the entire thing is free. So
that is amazing, Barry. Yeah, because I can tell, because I was just thinking, giving it out to people for 2 months, getting that those testimonials on board, because often so many industries are unwilling to kind of change, and there'll be a bunch of people in them, like the early adopters. That's cool. They're just they want it, but progressing on through to that next step. I've been reading a business book, and it used a term that I hadn't heard before, called the beachhead. Your beachhead, sort of the target market that you're going to sort of have ownership over when you first launch the product. It's called the beachhead product. And I'd never heard of beachhead, but apparently it's a military term. Milton was telling me about it.
Oh, yeah, like the D-Day beachhead or whatever, build up a beachhead and move
first
out.
place you land, take it over.
That's right.
And then there's neighbouring territories that you want to take over as well. Yeah. But you can't get them until you've got this. And it sounds like those testimonials for you will be super valuable. And it's worth cutting them a deal, right? Because it's so...
And that's it, exactly. So, it's not an all one-way street. We give them the use of software for 2 months. It allows them to get ahead of the curve and understand what carbon analysis actually looks like. It's also giving them access to cost data that architects have never really had before. So they're getting those benefits, and then we're going to give them discounted licenses on into the future as well to keep using it. But
totally.
The idea is that those 20, 30 users become advocates for us. You know,
Yeah,
they,
yeah.
and where we've had these conversations, you know, if you like the software,
Yeah.
can you go talk to 5 other architects and
Yeah.
tell them that you've liked the software and that we should use it? And we've already had that. We've had an architect down in Dunedin who's been referring us left, right and centre. He's been
Yeah.
using the software only for about a month now, and he thinks it's incredible.
And it's a competitive industry, and in order to be competitive or stay competitive, you've got to, you've got to evolve and change and take that stuff on. So, I mean, the people that will be those early adopters, if anything, I mean, it's making them stronger and it's giving them an advantage.
Yep, absolutely. This legislation is coming. You know what I mean? We have to reduce the
It's not
carbon.
going
There's no escaping
Yeah.
it.
Yeah.
So there's a number, you know, there's maybe 6% of the market understands that this is actually going to be a
Yeah.
substantial...
And political cycles just come and go,
Yeah.
you know.
Yeah.
I mean...
The commitments are there. We've
Yeah.
signed up to the Paris Climate
Yes.
Agreement.
Yep.
The national government as New Zealanders, we're going to end up paying for these carbon emissions one way or another.
Yeah.
We're either, when we get to 2030, chances are now
Right.
this is too late to really make any substantial changes. Like we have been reducing carbon for the last 17 years in increments. Not enough, but not reducing it, but reducing the growth of it.
Oh,
right?
yes.
Yeah. We're going to end up paying for it. When it comes to 2030, we won't have reduced it enough, so they'll end up paying for it through offsets. You know, there might be some worry that releasing this legislation is going to disrupt the construction market, is going to increase costs and all of that, and there may be some desire to avoid that, like the H1 standards around thermal performance of houses that came out two years ago. That was delayed for about 2 years because of COVID and because of construction industry costs.
Yeah.
The national could be looking at it the same way, but ultimately we're going to end up paying for it in offsetting anyway.
Yeah.
You know, so it's either get on with it and promote the likes of us as a solution. You know, we can find ways to reduce your carbon without costing you anything, or you pay for it in offset. You know?
Yeah.
We've got a great project up on the North Island. We worked with a developer, and this shows the power of what can be done, right? That's just missed opportunities. They had fully designed their building. They were ready to actually start building. They were ready to submit to consent for Hamilton District Council. They wanted to build five-story apartment blocks. So 5 buildings.
Yep.
They had designed them traditionally. So concrete tilt panel envelope, concrete foundations, 16-metre deep piles underneath the building, structural steel frame, concrete floors, and a steel frame roof. And they saw what was happening with this legislation. This is about 18 months ago, when it was still powering ahead that it was going to happen in 2024.
Yep.
They wanted to build more of these buildings in the future, not just these 5, and they wanted to keep replicating them. You know, and they said, right, well, this legislation is actually a risk to that future portfolio.
Yeah.
That what we've designed now won't work in the future. So they heard what we were doing. We had a beta version of our software at the time. They came to us and said, we have a fully completed design. Can you analyse it? And tell us how we should build it in the future. Yeah. So we ran it through our system, and within 24 hours we were back to them and basically said, we were able to say it to them because they
must have been a busy 24 hours though.
Well, the system does, the system does most of the work, so it's just running it through and analysing it. We were able to tell them within 24 hours that if they had built it as a hybrid design, right, which was a steel frame with CLT cross-laminated timber floors, cross-laminated external walls, and a timber roof rather than a steel roof. Right? That they would have reduced the carbon in their design by 3.75 million kg. Right? That's substantial.
Seems like huge. A lot.
It's huge. It's huge, right? Yeah. It's 5 buildings, so it's under $1 million per building, obviously, but it's still substantial when you add it up across 5 buildings. It would have reduced. It would have been cost neutral had they designed it like that day one. Now, considering. So when you go to design this next time for your next buildings, this is how you should build it, right? This is how you should tell your architects and engineers to start looking at this first, right? And it was also reducing the weight of the building by 1 million kg. Each building was 1 million kg lighter, right? By doing a hybrid. So we said to them, look, before you submit your consent, our advice is go talk to your engineer and your geotechnical engineer, because you've got substantial foundations underneath those buildings, right? See if that 1 million kg reduces the impact of your foundations and your piles in any way before you move on and actually submit that consent. They did, and the response they got back from their engineers was 1 million kg, which they verified, they peer reviewed it and said it's right. 1 million kg will eliminate the 16-metre deep piles. We don't need them anymore. We can just go to a shallow gravel raft, right? And it'll allow us to go 2 stories higher. So straight away, this developer went, why didn't we design it like this day one? I could have increased my yields with a high 2 extra floors, and I could have saved the money of not having to put in piles.
Yeah.
So he decided, I'm not building this building anymore. I'm going to go back and redesign it, because the savings from the piles will pay for me to redesign the building, and I'll get a higher return, a higher yield and profit, because I get 2 extra floors.
Yeah.
So he's scrapped his entire design.
And the long-term thing is to build more of them anyway. So if that one even came in at a loss, like future, it's just so much.
So we know how many buildings he wanted to build, and we were able to obviously say, right, well, if he had continued on and built them all traditionally, and he's now building them the way we've told him with a hybrid design, or the way VQuest has analysed it, we are potentially over the next the lifetime of his portfolio removing about 48 million kg of embodied carbon.
Wow!
I was just looking up what a million kgs. Is it about 10 tonne?
Yes.
Right? Man. Yeah. That's phenomenal.
Yeah, it's huge. You know, I think we worked it out that it's and I'd have to go back and look at this figure, but it's the equivalent of driving from the top of the North Island to the bottom of the South Island 10 or 12,000 times.
Whoa.
Yeah.
Okay.
Yeah.
Okay.
Yeah.
Wow, that's almost inconceivable. It's so large.
So the construction industry, what industries have we got that are the biggest? It's probably a difficult question, isn't it?
Yeah, well, construction, I can only really talk to the construction industry.
Yeah.
I have a rough idea what the other ones are. You know, agriculture, agriculture and power generation. You know, those kind of ones are up there. Actually, New Zealand is quite good for its power generation. I probably shouldn't say that. A lot of it is renewable energy. Yeah. But worldwide, it's one of the biggest ones. The construction industry, depending on country or depending on region, is usually between 18 and 25%.
Oh, yeah.
New Zealand will probably sit around 22, 23%.
Yeah. Ah, right. Far out.
Yeah.
There's
a big opportunity for construction to reduce carbon by nearly a quarter of our emissions.
Yeah. And what about commercial builds? Does this apply to like commercial, industrial, like residential? If someone's just building just a standalone house.
Yep. Again, we use a lot of timber in our residential, so our stick framing type construction. So it's from that perspective, it's already a low carbon. It's actually storing carbon material. So we're ahead of say European countries who build in concrete and brick. Okay. Because they don't typically use timber framing in Europe. It's mostly brick and concrete. So we're already ahead of them. So we're already on a good footing with our residential, but it doesn't mean there's not ways to reduce the carbon in the building. Your concrete foundations could be, you could have a low carbon or a carbon, like I was saying earlier on, in the future that will store carbon rather than emit carbon. Yeah. You use as many timber products in your cladding as opposed to fibre cement or brick. Timber cladding is, again, going to store carbon, whereas brick will be a large emitter. Reducing the steel, which there's not a lot of steel in our houses unless you're talking about an architectural house, but removing that and replacing it with, again, mass timber products like LVL. There's a couple of companies here in New Zealand, or there's one in particular, New Wall, who do aluminium joinery and cladding systems, and they're investing heavily in green aluminium. So to reduce the carbon in the production of their aluminium, So again, they're a forward-thinking company. They've already put their EPD together, their environmental product declaration. So we actually spoke to them at a conference last year, and they were way ahead of the game. They understood it. They understood the impact it was going to have on their market, and they put it in a fantastic way. In the future, we won't be competing on just cost. We'll be competing on carbon emissions. So architects will select based on our cost and our carbon emissions. If we're not performing on both, we won't get selected. Yeah. But if we fix this now, we're going to smash our competitors in the future because we're way so far ahead of them, you know what I mean? And we've invested in green materials or green aluminium production, which means that we've got a guaranteed source of materials that's going to be better than anybody else's. They're going to really struggle to compete with that, So the likes of New Wall are really advanced in their thinking. Yeah,
and your software totally shows that how closely linked those two variables are: the cost and the carbon.
So our software is an API plugin into design software.
Right.
So it's a button. You open up your software.
What is it? Yes. Yeah. So it integrates with what architects use, which is ArchiCAD and what is it?
Revit and SketchUp
Revit.
are the three big ones that they use. So we integrate it into all three of those. A lot of systems out there, for carbon measurement, because there are tools out there that will measure the carbon of the building, but that's all they do. They just measure it.
Right.
So it's effectively like telling you how big your problem is.
Yeah.
Yep.
And whereas what we're trying to do is solve the problem rather than just tell you how big the problem is that you have, A lot of those ones, what you got to do is finish your design and then export that data and import it into the software. What we've done is that's too hard. It's not intuitive. What we're going to do is try solving the problem, but also integrate it into the design process so that the architect can use it from the very, very beginning and use it right through their design process to optimize their design as they design rather than waiting to the end and exporting it to an external software.
Yeah.
So effectively what you do is you open up Revit or SketchUp or ArchiCAD, you start designing, you click the VQuest button and a second window will open up and it will sync with what you're designing. And whatever you've designed at that moment, it will start analysing how much carbon, how much cost, and how much those materials are weighing. So you can straight away start analysing the materials you're using and start comparing them to alternative materials and optimise the design right through the design process.
Yeah, that does give the architects a lot of power and kind of tools.
Yeah. But it's,
it takes a lot of pressure off as well.
It does, and it's again, we're not trying to replace quantity surveyors pricing buildings because there's far more metrics to just pricing a material when you're pricing a building, right? You've got that location issue with cost. You've got potentially ground conditions that might not be great, that or access conditions to a site that might be in the middle of a CBD. That pricing a material doesn't tell you that. It doesn't account for that.
No.
So quantity surveyors are still extremely valuable and will be still required at the end of those design phases to actually take all of the design information and do a full pricing of that project, right? What we're doing is providing enough information and enough data around carbon and cost that the architect can analyse an individual material or an individual methodology and say, this is the right one for this project, and then get to the end of their design stage, having optimised right through that design stage, knowing that they've selected the right material from a cost, carbon and weight perspective, then hand it to the quantity surveyor and say, can you do budget?
Yeah.
Can you produce the budget so that we know we're still on track overall for this entire project? So we're not trying to replace quantity surveyors by giving the cost data to architects.
Yeah.
We're trying to augment the process or make it more streamlined,
Yeah. And because, I don't know much about the construction industry at all, but we often see projects, especially around Christchurch, which go over time and over budget. Is that because, there's some global market and the price of the materials change? And
it usually it depends on the contract. Is from a legal perspective how you deal with extra cost.
Yeah, I see.
Usually when it runs over time, that has the effect of running over cost as well.
Yeah,
you know what I mean? Because more time on site means more cost. And the way the contract is put together will determine who pays for that. So traditionally what would have happened, and typically still happens, is a contractor would price a project knowing that it's going to be 18 months. And they will price that project and price all of their time-related pricing for 18 months. If through their failure they fail to deliver it in 18 months, they've got to pay for the extra time.
Yeah, I see.
This is simplifying it a lot.
Contract.
But if we say you get into the building and you realise that there's an issue with the design, there may have been an error in the design, or the client started making changes that delayed the project. No, that's the client's cost. You know what I mean? So there's multiple different reasons, and it gets way more complex than that.
Oh, totally.
But
look at our swimming pool. Complex, whatever it is.
Yeah, that's
man. You must just be looking at them going, what do you think about the stadium? Can you build a stadium out of wood?
It's funny. If you look at our Instagram account, you can build a stadium out of wood. Absolutely, you can. Yeah. It's funny. Our Instagram account, what we started doing is going around Christchurch and taking photos of buildings and actually showing how much carbon. Just a flat.
Please, Barry, don't, because it's such a hot topic at the moment, and all of the ratepayers are
Yeah.
You know, complaining and whinging and moaning.
Yeah,
you
we're
see
not putting-
screeds of comments on articles when they talk about the mention
this
the
is
stadium.
This is more simplistic than you know. We're not sharing costs. What we're doing is we're just saying, you know, here's a material.
Yeah.
Here's typically how much carbon is in a square meter of this material.
Yeah,
You know what I
yeah.
mean? And we've done it for the stadium. So we put up on our Instagram account. We just drew up a splat kind of diagram that said this material has this much carbon, and looking at the steel and looking at the concrete and all that. You know, so I see opportunities everywhere I go. Like that project on the North Island was a great example of missed opportunity.
Yeah.
It would have cost that client nothing to design it the
Yeah.
way we had told them to design it if they'd done it day one. And we see that everywhere. We see it like on the East Frame where they're building those houses over there in concrete tilt panels and brickwork and all that. And structural steel. We're looking at that and we're saying we can prove, because we've already done it with this one on the North Island, that there is a way to make this more sustainable, that you've just missed the opportunity, you know? So I look at the stadium and I kind of go, you know, that's a massive carbon emitter. It is huge. It is because it's steel and concrete. There is no timber in it. Very, very little timber in it. You know, very little sustainable products are all considered in that building. Now, it is also very difficult to build it any other way because it's massive, massive structure. But it doesn't mean it's impossible. I think with a stadium like that, we would have been paying a premium for a mass timber building. But there's so many other metrics there that that need to be considered as well. Like, it would have been quicker to build mass timber. It would have been better for the environment. It would have been nicer to be in. Then look, you know, it's a warmer product. Mass timber is a warmer product. They call it biophilic design. They've actually got science behind data there, or scientific data there, that shows that people prefer to be in these buildings and feel happier and healthier in mass timber buildings. You know? It's amazing. Some of that research is fantastic. And I've been in mass timber buildings. The Epic Centre, you know, the Epic Innovation Centre down here on it's at Tuam Street. The one that used to be the old BNZ.
Yeah, I know.
Innovation Centre. If you walk into that building, it's from the outside, it just looks like a big metal box.
Yes.
You walk in there and you suddenly realise this building is a full mass timber building, and it's beautiful to walk through. And it's comfortable and it feels warm. You know. Yeah.
There's something about that psychology or whatever. There's something in us, where we respond to it.
Yeah.
I like that biophilic.
Yeah.
So I think bio means life and philic means, you know, getting attracted to or whatever.
I think we've talked about that in the past with hospitals, and how, you know, a space like that needs to be really considerate towards the healing nature of it all and stuff. And little details like that can make a massive difference. I mean, they probably... I mean, in the 90s, I remember them introducing atriums and stuff. Remember atriums? No one talks about atriums these days. It's like, there's an atrium. It's like got green plants in it and crap.
But it's nice walking into a big, beautiful atrium. It is psychologically appealing, you know?
Yeah, no, it's really cool.
Must make your day a tiny little bit better.
I think so. You know, it's even if you go into this the 231 High Street building here that you've had Mr. G on before on one of your podcasts. He's one of the advocates and one of the custodians for that area. It's a what do you call it? Co-working space. It's very basic, but it's fantastic for startup companies. But one of the things Mr. G and his partner have done is they've gone through that building knowing that it's got no carpet, it's, you know, exposed ceilings, and it can feel cold. She's gone through there and they put plants everywhere. And it feels, you know, it does make a difference. You go in there and it feels healthier, it's nicer to look at, you know what I mean? And, you know, so it's just little things like, you know, around that biophilic design, 100%. Put plants everywhere.
Yep.
You know, it's
I
cool.
mean, the opposite to that, I was looking at the Grenfell Tower. Do you remember that, mate? And they had the outside cladding was made of some sort of aluminium composite, and it all went up in flames. I mean, that's the opposite to biophilic.
It pretty much is.
What biophobic. No, mate, that's terrible, but that just make all those products that are out there that are like toxic and dangerous.
There's other systems out there like the Living Building Challenge that address toxic materials. So you've got the New Zealand Green Building Council that looks after sustainable building. They promote sustainable building. They're out there to try and encourage people to use sustainable materials. There's another one then called the Living Building Challenge, which looks at your building's toxicity. So it has a blacklist of materials that say you can't use these materials. If you use these materials, you fail to achieve our outcomes or Living Building Challenge. You know, so there's all these different programs out there that you can help to build buildings better. You know what I mean? Sometimes it can be confusing, and they're all trying to achieve little different things.
That could be another metric, which could be included in your software. Because often we hear, I can't remember what it is, whether it's chipboard or just plywood with formaldehyde or something or other.
Yeah.
I've certainly heard of it myself, and I'm not even involved in the industry, but I know that there's some kind of connection between the two.
Yep.
And it's kind of like, should you use it? Shouldn't you?
It's a bit like the asbestos all over again. You know, asbestos of the 60s, 70s, and 80s, and even into the 90s.
Yep.
That MDF material and the silica bench tops and things like that, they've only now just discovered in the last 10 years that actually they could have been doing just as much damage from a builder's perspective, not necessarily the user perspective like asbestos, but from a builder's perspective, they're quite toxic as well.
Yeah,
you know?
cutting it, drilling it, all of that type of thing. Yeah, silica.
Yes, it's that sharp silica, it's like glass, right?
That's right.
Particles getting into your lungs.
And the MDF goes down into your lungs, the dust from the MDF, because it's a combination of glue and dust, effectively becomes glue again back inside your lungs.
Wow.
You know?
Yeah. If you like the smell of it, you're in big trouble.
Yeah, some of those old toxic stuff that smells real great.
Yeah. I remember
high.
kids at school sniffing on a Vivid or something like that or something. They're just like, man, I love the smell.
So basically you're at the forefront of a major sea change.
Yeah, we believe it will be, because we believe it's unavoidable. We're going to have to reduce carbon. Unless there's some technology out there that they produce that, absorbs all the carbon around us. You know what I mean? Some mechanical system or something that they put out of the ocean, and overnight it changes everything. That's, unless we have something like that, and there's nothing really like that on the horizon. Unless we have something like that, we still need to address the way we're building. And even if they did come up with that technology, as custodians of this world, we should still be building in a more sustainable, better way. It makes sense.
Yeah, less toxic. Yeah. Do you? I came across Tech Fest.
Yes. Yeah.
But can you tell us a little bit about that?
Yeah,
it's coming up at the end of May.
Correct, yeah. So it's Canterbury Tech is an organisation here that promotes, probably one of the best ones in the country for promoting startup companies and new technologies. They run regular events, regular webinars, speaking opportunities. In May they run TechFest, which is an annual, basically a conference almost that new innovators get to actually get up and stand and tell people about their products. And on different days they have different topics. I'll be speaking at it this year on Thursday, and I think it's the 23rd or 25th. And that day's topic is sustainability. So yeah, we'll be presenting on that day.
Brilliant.
Sweet.
Yeah.
So it sounds like a bit of a hotbed of inspiration and excitement and
yeah. As I was saying, Canterbury Tech are kind of one of those companies or one of those organisations. There's multiple around New Zealand, but they're probably one of the best run, most dynamic ones for promoting the companies that are coming out here in New Zealand, and coming out in Canterbury. Yeah, it's a dynamic area.
So do you think Christchurch has a unique sort of role as opposed to other centres in New Zealand? I think with the atmosphere in the city being new and dynamic, I think it kind of lends itself towards itself. That's not to say, Auckland has their own version of MOA, or Ministry of Awesome. So does Wellington, and it's great to see all of those programs everywhere because it's needed everywhere, those startup companies need that support, but I think Christchurch actually is primed for it. It's a great hub in the South Island. It's got the infrastructure around it, to get around the South Island relatively quickly. And it's got, this, as I said, this new dynamic vibe to it. So yeah, it's quite. I think there's going to be a lot of startups that you're going to see in the next couple of years come out of Christchurch. There is some fantastic ones over the last couple of years, like Piper Vision. Have you heard of those guys? No, I haven't.
Yeah, so they like, their idea is fantastic. They remove fog from around airports. They send drones up, and it's sustainable. It just basically goes up. It can remove fog in the space of an hour around an entire airport. And it's just an amazing technology. And they're out of Christchurch.
But I was just looking at
that is so cool.
It came up on my YouTube feed. The Tenerife. It was the worst aircraft accident ever. It was like, I think it was in the 1970s. But that was caused from fog in an airport. Like one airliner took off and didn't realise there's another airliner on the runway.
Yeah.
So a lot of people died. But that was caused from fog.
Yeah, so it's it's multiple, again, complicated scenario where it's more than just health and safety. Health and safety obviously being really important, but cost of the airports, cost of the airlines of having grounded flights and people, hanging around in airports, and when they could be getting more flights up in the air, so it's again, it's
this constant look at this multi-variable.
It is, but it's what I find amazing about it is that everybody has just always accepted fog. There's nothing you can do about it.
Yeah.
Whereas Hypervision, a Christchurch-based company, has decided, no, there is something we can do about this. We'll fix that.
That is remarkable. That's where technology is just helping all of a sudden.
There's another one.
Utilised.
There's another one that I absolutely love. Come from Ireland and agriculture, and I grew up in a rural area. I've seen how farmers work, and they're the fact that they have to get up really early in the morning, and milk the cows, bring the cows in, and all that. There's a company again out of Christchurch. I think they're Christchurch. They're called Halter, and they've built fenceless farms. So you basically put a very cheap collar on all your cows. You don't need electric fences. The cows know that they can't go beyond the boundary. The collar basically gives them a vibration to prevent them from going beyond the boundary. But the farmer from his own kitchen can basically draw those boundaries in an app, right?
Cool.
And keep them in the field, right?
Yeah.
And then when it comes to, and he can automate all of this, when it comes to milking time, he can change those boundaries so that he corrals the cows to the milking parlour. Yeah. And all these new milking parlours now are automated as well, where the cow can just walk in and be milked, and then change the boundaries and send them back out to the field.
It's so clever.
Yeah, it's just, all these amazing innovative ideas, and they're happening in Christchurch,
Yeah.
Yeah, there was another one.
We need one for children. So can get the kids up. Just a small little collar that they could wear. Get some vibrations, move them into the bathroom, brush their teeth.
It's an ongoing challenge. I sent my boy out to school last week and had put his fully ironed uniform in his wardrobe. And he got to school, and I got a message halfway through the day saying they'd realised he wasn't wearing the right shirt. He was wearing a white shirt. He just pulled out of the wardrobe. He didn't care. He was just like 14-year-old. It's a white shirt. It'll do. Missing the crest and all of that. And
that's not too bad though. At least he had a shirt on.
He had a shirt on. Yeah. He's got a 10-year-old brother, and I've had days where he's come out wearing his clothes.
Yeah, wow.
And you're going, I don't think they were meant to be skinny jeans.
Yeah. I have a niece that got all the way to school being dropped off by her parents who didn't have her shoes.
Wow.
Yeah. And the parents were like, we're not going to do anything about it. That's your problem.
Yeah, it's a way to
off you go.
Listen,
It's a great lesson.
Yep.
Anyway, back to the tech. Sorry. Yeah. Hey, that's awesome, Barry. Thanks for telling us about everything, and it's cool to hear that you're going to be talking at the Tech Fest.
Yep.
It's amazing to hear about this dynamic innovations like the halters, the defogging at the airport, and what you guys are doing. Yeah. Man, there's so much stuff going on.
Yeah, just have a look at the MOA, Ministry of Awesome website, because they've got a blurb up around all of the everybody who's been through there and everybody who's currently going through there. And you just look at some of the ideas and you're going to go, oh, man, some of those are game changers. They're and just fantastic ideas, Yeah. Some of them are fun, some of them are practical, some of them, will change the world, other ones will change Canterbury or New Zealand, and it's just really cool. Yeah.
So do you like, this is probably going to sound like a stupid question, but do you want more customers? Do you want more architects? Do you want more development companies like construction companies?
Okay, so part of, again, Ministry of Awesome was that they were brilliant at tutoring us as to, understanding what your market is, what I mean? And they've got a process called Ideal Customer Profile. So where you examine all of the possible customers and you say, right, well, who's our number one, who's our number two, who's our number three, either from a demographic or from an industry or wherever, Our ICP1, our Ideal Customer Profile number one, is architects in that small to medium size.
Cool.
Yeah, they can make the biggest impact. There's more of them. than your bigger design practices, you know, your
Oh,
Beckers
sweet.
and your Warren O'Mahony's. It's small to medium size ones are ICP.
Right.
And
Yep.
we do need more of them. They're
Yeah.
you know what I mean? And there's a lot of them in New Zealand, so there's a big market to
Yeah,
plug into.
yeah, yep.
Our ICP2 is the same metric of small to medium, but it's for engineers. Because engineers can use this software as well to look at the frame and structure of the building. And then our ICP3, which is where we will draw the line, is design and build contractors. So the likes of Calder Stewart,
Lee's Construction, are they one or not?
they're not
No?
really design and build. What they will do is
Calder
they'll
Stewart.
engage an external architect.
Right.
The likes of Ryman Healthcare.
Oh, yeah.
So they're design and build. They employ in-house architects and engineers to design.
Oh,
their
I
buildings.
see.
That's
So
kind of what
Williams Corp or
no, Williams
no.
Corp again. They engage external architects to design their buildings for them.
Right.
You know, so it's if they've employed
Sorry.
an architect under
Yeah.
their payroll, that's a design and build. You know what I
Yeah,
mean? So
I see,
Calder
I
Stewart do a
see.
lot of their own development, so have their own architects in house.
Yeah.
It's those guys because again they've employed the people who would effectively be our ICP1.
Do those other ones go out to tender for designs?
Correct.
Yeah, I
they
see.
would do. Yeah,
Yeah.
or they'd work with a preferred supplier. You know.
Yeah,
They-
yeah.
Somebody they've got a track record with.
Yeah.
Yeah.
Awesome. So what's a small to medium sized architecture firm? Like, is that like 50 people or?
It's one to about 20.
1 to
is
20.
Kind of
Okay.
what we're saying. The reason it's important is because, as we were saying earlier on, or the reason they're important is because nobody's going to escape this compliance when this legislation comes out. You're going to have to fill out the compliance documentation when you submit for your building consent. And MBIE have a tool that it's a brands tool. So brands have developed a tool MBIE are going to use for compliance. It's called LCA Quick. It's Excel based, and it is about 15-20 tabs long. And we ran it on a house, just a house, your simple average, 180 square meter house. It took us, and we knew what we were doing, we knew how to use it. It took us 6 hours to fill in the document for a house. Now, 6 hours at an architectural fee that's going to be passed on to a client is substantial, and that's just a house. You move that up to a $10-20 million project, and it could be hundreds of hours. So. Or we've got that optimizer tool that I spoke about earlier on that plugs into the design software, but we've also got an export tool that has actually automated LCA Quick and the NZGBC's Green Star tool as well. So we've automated both of them so that 6 hours that you'd have on a domestic house that you're going to have to submit as compliance is now instant. You don't have to do anything. You just click the export button, it populates that compliance document for you. So it's saving an architect potentially 6 to 20 hours on every domestic house. On a commercial project, it could be saving hundreds of hours on every single project.
Wow.
Yep.
That's cool. That's cool. They will love that.
Yeah. It's, when you see the MBIE tool, it's a fantastic tool. Don't get me wrong. It is a great tool. It's a great scientifically based tool.
Yeah.
But from a compliance perspective, it's going to be a nightmare. It's going to be real. It's going
Yeah.
to be a lot of resource, a lot of headaches, and a lot of confusion using
Yeah.
it because it is a complicated document.
Man, if you can eliminate that substantially reduce it, that's awesome.
And I think it is.
I mean,
most of those compliance documents that are coming out worldwide are very similar. Australia, we've seen the one that Australia want to release, and it's very, very similar, eerily similar to the one that New Zealand is going to release.
Yeah. Now, people in all industries hate that red tape, hate that kind of. It's not often that they hate it because of the end result. It's just the process, They hate the process. It's just like, ugh.
Yeah. But those the H1 requirements I mentioned earlier on, that was the change to the insulation and thermal performances of houses and the standards. So it meant basically our windows and doors had to perform better and our insulation has to perform better in our new houses. That came out about 2 years ago now. We spoke to a number of architects when that came out and we said, how much of a headache was that for you? And they went, a little bit. And we kind of went, okay, we thought that was going to be a bigger headache. How long does it take you to do it? Oh, no, it takes a bit of time, all right. And we're like, well, that's a problem. That needs to be solved. Somebody in the market needs to solve that, come up with a piece of software that does it for you. So that's the business case we're running at the moment, is because, again, it's just data metrics, it's performance metrics. We could build it into our software. Now, we're concentrating on carbon because legislation is coming around that and nobody else is doing it in a good way. So that's our market, but we will definitely go back and look at the H1. There are other solutions out there to it. They're not fantastic. We believe we can do something better, but it's a business case that we're concentrating on something else now. But we'll go back and we'll look at H1 as well.
So how many employees have you got?
There is 3 of us involved. Yeah, yeah.
Wow,
Yeah.
that's impressive.
Yep, but hoping to scale. As soon as the product is out there now, we
Yeah.
need to build a bit of
Yeah.
revenue, and as soon as we have
Yes.
good revenue in, the intention is to scale. Yeah,
Oh, it's exciting. I can't wait to hear more. Like in a year's time, a year's time is a lifetime in a that quick growth,
it is. Yeah,
Yeah.
yeah. It's an important year, this first one. Yeah.
Yeah, that's right. Cool. Thanks, Barry.
Yeah, thanks, man.
Cheers, Malcolm.
Breakfast.
Oh, yeah.
Mustn't forget that. Here we are. Here's the menu. Cool. Yeah.
I like porridge. I love porridge.
Porridge. Okay,
Excellent.
mate.
Sweet
Yeah,
as.
no problem.
Alrighty,
Yeah.
Barry.
Cheers,
Catch you
mate.
later.
Cool.